Oh my God. It still annoys me to this day.
What's going on, vlog? Our daily vlogs have now officially become a mess because, especially for yesterday's vlog that's supposed to come out, I'm going to do commentary today for yesterday, and everything's just a mess right now. But hopefully I get it all settled, get it all fixed up today, doing some more editing for yesterday's vlog and then today's vlog. So it's going to be a crazy day. And then I have something else I need to work on from about 4 to 7. So that will be quite interesting. But I wasn't able to get everything I want to get done yesterday, which is why everything's piled on today. But hopefully, if I'm able to pull it off, then that means tomorrow we get to do our first live coding session, which will be a lot of fun and something I'm really looking forward to. So yeah, let's get to it. There's no time to waste. It's already like 12 p.m. So the Sunday's already almost over. So let's get to it.
Okay, so now that we have the neural network library fully up and running, let's now put it all together and create what were we creating again? DeepQ, and create the DeepQ agent. Okay, so let's evolve our Q learning into DeepQ learning. And so to do that, we're basically just going to replace the whole Q table, and we're going to replace it with a neural network instead. First things first, let's import all of our files that we've created here. Okay, let's actually get started with hooking this up. Okay, so we first need a local, we need to define an approximator. Okay, so that's our approximator.
Okay, so apparently I didn't record any footage for this last part. So I'm just gonna have to walk you through line by line the code. But the problem here is the last time I touched this code was like a while ago. I would say the last time I took a look at this code was all the way back in January, and it's September right now. So I've forgotten a lot of the stuff that's in this code, but let me just kind of walk you through how I hooked up the Q learner with a neural network to form a deep Q learning AI. I've tested it out. From what I remember, it works decently well, but let's just go through it and let me just explain things by little. So yeah, I mean, generally speaking, you have your oh, this is the train DeepQ learner state. So it was actually a hassle to implement because there's a lot of stuff in here that messed up with everything I was coding. But so one thing I implemented here is a cyclic buffer. So essentially that means that when the AI is playing the game, what it does is it stores game states and actions in memory, and it does it in like a cyclical memory type of thing. So let's say you have 10 memory slots. It's basically like a first in it's basically like a queue essentially, right? So it stacks up from 1 2 3 4 5 6 7 8 9 10, and then once it's at 10 it just goes back to 1 and it starts overriding the information that's there. So it's kind of cyclical in that regard, and so that's just to keep track of what the game state, what moves it made, so it can kind of start learning from its moves and start learning what are good moves in which game states versus what are bad moves in other games. So that's what that is. Encoding functions, that's just to take the game of XOXO and then convert it to numbers. So I experimented with a couple of different ones. So too technical, so I won't necessarily go over it. But for anyone's interested, I implemented effects coding and dummy coding and binary coding. So all three of them. I remember testing it out, and I believe that the one that I liked the most was the effects coding. I cannot remember though, but again, because this was a while ago. So yeah, the Q learner, just initialize the parameters of it, the batch size, the encoding technique, dummy coding, I guess is what I prefer to use here. So yeah, you initialize the neural network, and I think, yeah, so just using leaky relu for the hidden layers here, and then using also dropout for the hidden layers as well. So that was also implemented into my neural network library. So the output goes through the identity function, and that's just to keep it, because at the end of the day, we are trying to guess what the Q value is, and so I didn't want it to be bound by between like 0 and 1, for example, for sigmoid, or -1 and 1 for tan. I just wanted the raw output because I wanted to be able to guess or approximate what the Q value. So that's why I'm using identity there. Optimizer, I'm just using the normal stochastic gradient descent. Now, why am I using it? It's because what I've read is that it's not like, it's obviously Atom is better, but Atom cannot generalize as well as just normal SGD can. And so that's why I stuck with it. For update, Nesterhov's momentum update. This was a hassle to implement, but this is where Excel came in very handy, because I actually implemented this in Excel first before I came and I implemented it. So that was a lot of fun implementing that. And so just moving on, yeah, so you can see it's pretty fully featured, right? I have the learning rate, I have mu, I have decay and momentum decay in here. Just moving on, just moving through, I've implemented functions and features where it updates the QLearner model. Here's kind of the memory function. So this is for the buffer itself, and this is sampling. We're sampling episodes within memory, and this is, again, these are all just memory functions. And so now we're kind of getting into more like the Q learner function. So again, getting best future, finding the best future reward. I will say that there was one thing, I think it was here, it was this line. Like, holy cow, you have no clue how much headache that line gave me, because what would happen is, so when the game is over and you can't play anything, you're supposed to tell the algorithm that there's no reward for a state where the game is already over. And so it won't try, so because it knows the game's over and there's no reward, there's no reason, or there's no reason for it to play anything. But I had that line commented out. I can't remember why I commented it out, but this line wasted weeks and weeks and weeks of my time, because what would happen is, and I thought there was something wrong with my neural network library, what would happen is the AI would train, and so at the very beginning it would train, and because it doesn't get to the end state that often, that won't influence the training. But then as training, and so it would get better and better and better, and it hit that end state a lot more. But then as it gets towards the end of the game, or as it gets better and starts hitting the end game more, because it's not realizing that, oh, the game is over, it then starts making up random moves that it can do at like a game that's already ended. And so that would then mess up the whole network. It would essentially, it would be really, 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 really good, and then it looked like it would unlearn everything. So I thought there was something wrong with like the architecture of my network, but because yeah, it would get really good, know how to finish and end off games, and then all of a sudden it would just start doing random stuff and start learning random things. And it was because of this one damn line that I forgot, just to tell it that, yo, when the game is over, there's no reward that you can get for an end game state. Oh my god. It still annoys me to this day. Yeah, so just standard stuff. Pick and make a move after you go through the neural network. Get Q values, so essentially just call the neural network and just feed forward, and if there's a mask, apply a mask. So this is interesting. So I had to apply a mask because this is a tic-tac-toe game, and so not all moves will be valid, and so like there were a lot of things that I was trying to implement all at once. And so that one line that I showed you earlier, that plus the mask just made debugging and trying to figure out exactly what was going on quite difficult. But yeah, so the mask is there again just to prevent the AI from having to learn that, oh hey, these states aren't valid, but also preventing it from actually picking those invalid states in the first place. And so that's what that is. I'll play around with what happens if I don't have a mask implemented, but for now that is there. And yeah, so this is where it just figures out where the legal moves are, and then it creates the mask here. And then yeah, I just have a whole bunch of helper functions at the bottom here. So that is that, and that's how that's implemented. Now question is, how does it work? Well, it works really, really well. Let me see if I can actually pull it up, or pull up a. So it works really, really well. The only thing is, and I was planning on doing this at the very end, but it just needs a little bit of training. but even with days and days and days of training, search still beats it out. And so yeah, yeah, I'm trying to. So I mean, it does decently well. So here it is going up against naive AI. This is a fully trained neural network. Let me see if I can speed it up. If I remember the command that I put in for speed up, what was the command? Oh, okay, just left and right keys. So yeah, I mean here it is. It's going up against naive. Now this is a trained deep Q neural network. I don't know. I can't remember how long I trained it for, but what you'll see is if I fast forward, what you'll see is it's still not perfect because it's still losing some games to naive AI, and so that is quite annoying to me. But I think I figured out why. And so tomorrow during the live coding session, what I'll be doing is I'll be trying to debug this and see whether or not there are ways I can fix this. I think the issue is so in the algorithm for DeepQ, what I have done is I only implement one neural network that's shared between both DeepQ agents because it's just using one network. I think that's what the issue is. So yeah, no matter what epsilon I set or no matter what exploration rate I set, it still seems to just, if one network or whenever it finds a decent solution, both agents will just start exploiting that solution. And so what I need to implement, or what I want to implement, is the ability to have two different networks in here. And so both networks will be going up against each other and will be learning against each other. And so I think that's what will help, that will help it, unless I make it go up against search. But what I want to do at the end is make DeepQ and search and the other algorithms I create go up against each other. So yeah, I mean, we'll see. I'll try to work on that tomorrow, and we'll see what happens. And hopefully this adds more content and more meat to the vlog. And I'll see you guys bright and early tomorrow. Have a good night, guys.